why we are here is a good question, because it actually was of this man that we are here, Professor Friedel Selschop, for one of the stars for many years of the university. And he led this nuclear physics research unit, later became the Schollner Research Center. And he was a man that had a great passion for multidisciplinary interconnectivity of scientists. I could tell stories and stories, but basically we were tea time. There was an engineer talking to a mineralogist, talking to a physicist, an applied mathematician. We were all there, a bunch of young and old people from different parts of the world, often traveling. And he had two passions, however, among the many as a physicist. One passion was diamond, and the other passion was for funny geological things, like Fredefort Dome. So Roger Hart was my buddy and my mentor. He introduced me to Fredefort, but my task that was entitled just after my PhD was to look at the geochemistry and the origin of diamond. Big problem was that there was an experiment done in the late 70s that was very successful, but had a little drawback. The diamonds, like this one, a beautiful set of diamonds that were given by a well-known but not mentioned company, were radioactive and not exactly as colorless like that. So I had to find a way of doing research on diamonds without actually having diamonds. Not a very easy thing. But anyway, so reading through the literature, spent I think a year just making photocopies, I found that there was something that was made of diamond and you could actually buy on the free market almost, or through colleagues at the university. So I found that there were carbonado diamonds, the ugliest possible form of diamond. You can see no lady would dare accept this as a token of eternal love. And yet, for a scientist, they are far more interesting than the other one. They are ugly, yes, full of holes, but they are easy, cheap, and they're full of strange minerals, something that you find only meteorites, and others that you find in granites, and some that you find. So people still now, after 50 years of studying them, still don't know what happened. Somebody will tell you that they come from a carbon star, and they have some reason to say that. They say, no, it's rubbish. They come from some deep part of the earth that have not been probed. Others say, no, you got all it wrong. They come from bog, where there is mud and organics and there is uranium. All of them cannot be right, but where they come from. So that was something that a young PhD really wants to put his teeth on. But unfortunately, life goes on. Prof. Selschop eventually had to retire, died. The history closed the university, the Schollner Center. I had to go to work and looking for where the next nuclear power station or what we do for nuclear research, nuclear fuel or spent fuel, this kind of thing. But so I kept this interesting. That there must be something interesting in those things if nobody seems to find where they come from. So over the years, I always stealing time here and there, getting some stones here and there, but nothing really happened until I was at a conference which was organized by Roger and his colleagues at the university, where we had a lot of scientists looking for meteoritic phenomena, and this gentleman came along. This is an astronomer from the university, from the Turin institution, that institution that gave us the Turin scale of catastrophes of cosmic origin, more or less the Mercalli of impact. And Mario told me that, interesting that you're interested in carbonado, because a friend of mine in Bologna has got a museum and he has 2 carbonados from Egypt. Oh, that's interesting. The wrong part of the world. The carbonados are only known from two parts, Brazil and the Central African Republic. Everybody knows where that is now. But we are quite far from this area here, the Libyan desert glass area. So I said, bring it on. We have a lot of technology at NECSA. We can do something. And so this gentleman, who incidentally was one of the discoverer of the youngest meteorite crater, proper meteorite crater in the world, the youngest and the smallest. It's somewhere in Egypt. I've forgotten now where it is, but he found big pieces of iron and so on. So he sent me the stones, 2 stones there. You can see them there. You can hardly see, or they were picked up in this fascinating area, an area that has been puzzling people for thousands of years, but in general, but specifically for 60 years. The area of the Libyan desert glass. This area here, the Libyan desert glass, is an area that at one stage, 28 million years ago, was a big pool of molten desert sand. An extraordinary heat had happened to disintegrate almost that region. And, but now you still pick up these magnificent stones of glass and with very iridescent, very color. Apparently during sunset, the sun is glowing, it's setting sun, they come to life almost, eerie. So a lot of publication, a lot of speculation, a lot of mystic people attributing, and you can look on the internet on this, you will spend an interesting evening. So much that even Tutankhamun, when he saw one of his jewelers, he said, that I like, I want to have it on my, when I become a mummy, and I want to have it with me because it will keep me safe in them. So this one of the gentlemen in our scientific team in Italy, the Italian team, actually saw the stones at the museum in Egypt, and he, with his experience, been for 60 years a curator of a museum of Milano, he knew that that was that material. So he did the publication, and they had a conference. And so the Libyan desert glass looks like the area, looks like this. Millions of stones everywhere, stones, and of various colors, gray, dark, gray, black. But there was one that attracted the eye of an Egyptian gentleman, Ali Barakat. Ali Barakat obviously knows the area quite well. He's been in this region with expeditions for many times, and he saw this black stone that was sticking out somehow. I think it was like Professor Kitching of this university. Professor Kitching from this university, you could drop any place in the world, within 10 minutes you would find a fossil that nobody has seen before. This guy had saw that this stone was different. So he took it to the lab. He didn't know what to do, so he cut it as we do, a petrologist, with a diamond blade, and he disintegrated the diamond, the saw. Probably there was one of those explosions of gas that you will hear later from Professor Kramer. So this, then he did a PhD on this thing, but the technology wasn't there to unlock, to unpack the science that we can do. So eventually this stone, this is a fragment that was given to me for study, is there. Came here with the other 2 stones from the Museum of Bologna, and we were able to put them to the test with our machines that are also available at WITS, but I'm at Pelindaba, and it's very easy to walk across, and some of my colleagues are here. And for instance, so patients couldn't be here tonight for family reason, but we started probing and zapping. We did tomography, microscopic scale tomography of this thing, like a CAT scan, but on the stone that is a few millimeters long. And we started see things that were really very, very strange. It's everything shattered. So it's so hard that you can destroy a diamond blade that you can cut any granite. It's full of fracture, cracks everywhere. And then there are even strange patterns that nobody still know what they are. It's science in progress. So that was the first experiment. Then we moved to patients, which is very patiently put the beam of the electron microscope, scanning electron microscope with an attachment to analyze the materials, and we could see that these paler patches were just diamond or very hard carbon-rich material. But then it came to these dark patches that are all over. And that is where I lost my patience, because she kept giving me wrong analysis. You can't have an analysis with a 31% atomic proportion of oxygen and only less than 1% of all the other metals that should make oxide. It's possible, it can be wrong. So for a year, I did not believe that this was true. I went from lab to lab, all good friends of mine, all people that I trusted, but I continued to disbelieve them. Eventually, I asked another colleague of mine who has a contraption dating back to the early 50s, to the days of the Cold War. It's a machine as big as a building. It's called the Van der Graaf accelerator. And he zapped the stone with deuterium hydrogen, heavy hydrogen. And it triggered a nuclear reaction that, which is to prove that there is oxygen or not, or nitrogen. And it did prove that there was hydrogen. And this was important because it was a non-X-ray based analytical technique. So I had to say, well, okay, all right. Then there is something really interesting here. So I can start to get a little bit excited. Before that, I tried not to. Then we started to look at the metals that were interspersed with the carbon, and the nickel was there. Nickel is nice because in the middle of the desert, you shouldn't have nickel like you shouldn't have diamond. But nickel tells about meteoritic. But the ratio chrome to nickel is wrong. Mainly iron, and then a little bit of chrome, 3%, the other is 15%, and a little bit of nickel. So it wasn't a meteoritic from that point of view. Then another bomb. This was was done with Michael Whitcomb. I mean that he was already an engineer working in electron microscope, where I was a student at WITS, so I knew I could trust him. And we fiddled around for a day or so with electron microscope, and I wasn't particularly excited what I could see. Then at one moment, he flashed this image and said, wow, I see something. It's unique. I don't know what it is, but it must be interesting. Then talking to physicists, and I went to the physics department and to here at WITS, and I asked other people, and they said, well, they look like cosmic rays, traces of cosmic particles coming as they come into the atmosphere at ridiculous speeds, and they interact with the atoms of the upper atmosphere. They make the showers. Here there is a shower going there, this shower going there. But these, then we analyzed, they are iron, nickel, sulfur. Oh, good heaven. And this is through diamond. So, really weird, even more. Then I asked him, there is something there that my specialty is actually a petrographer. That is where I've done my PhD. So in other words, my special expertise, if I want to have one, is to look under the microscope and look at textures. And there was something there. So I asked, please, can you do something? And he, being a master of electron microscopy, Michael, he produced these images, enhanced the contrast, and this maps out oxygen. You will hear more about these gases and oxygen in the from my colleague, Professor Kramer. And so this texture I've never seen been. I mean, I've been around the block, been a retired geologist, and okay, but in 40, 50, never seen anything like that. Swarms of oxygen going through something as hard as diamond, and we know now there are diamonds. But the diamonds are so small that there would be 100 of this bar, or less than 100 parts. You take this 100, and so in other ways, the diamonds are tiny little speck here and there, disseminated in what is some kind of carbon, which we are working on with Lady Vittoria in France, who is a specialist in Raman spectroscopy. And maybe it's a different kind of carbon that we don't know, because you will hear what it does with this oxygen. Okay, so basically, this was an Arnie experience. The wow, when the dopamine starts flooding the brain, and you are, as you are like in a legal moment of equivalent that you have to pay, otherwise LSD, where you don't know, you just see that you open the door of something that you thought it was a meteorite maybe, or an impact-related object. There's a world outside. It's a new horizons. And you want to call in friends and come, let's go. Like she called her cousins and the Pevenses, and they went in and they had wonderful adventures. I had an opportunity to meet now my friend among those that joined me in going through the door, Professor Kramer, and he will then tell you obviously what he found. At that stage, as a petrographer and a petrologist, I could come to a number of conclusions. Sorry, that the rock is rich in nanodiamonds, that is rich in amorphous so-called carbon, but is loaded in gases, that is a host of meteoritic kind of metal of some kind, chrome, nickel, iron, but it has textures that are more in common with astrophysics than with geology. Is found in an area that was shocked by a massive air burst like the one that million or billion times bigger than Chelyabinsk. And too carbon-rich to not be any known meteorite, but it had some kind of affinity with the debris of space dust that is collected by NASA and this big organization. So the suspicion came, can this be a comet fragment? So prima facie, there is evidence that it can be a comet, but as we all know, to prove that something is formally, it's a little bit more difficult. So why we also gave I don't know why that came across, sorry for that, Hypatia, the name we gave to the stones, and possibly to the comets. Comets are beautiful, mysterious bringers of life, and dramas too. Hypatia lived in Egypt, so that makes a good reason for a name. Was the first woman mathematician, astronomer, good to tick, a philosopher. If it was today, she would be the director of the MIT. And she only has a crater on the moon that nobody knows where it is, and also an asteroid that is not particularly nice, I'm sure, it's somewhere. So I think a comet will be much more feminine and elegant and fascinating. And here we are. Now Jan will tell us what he discovered in the movie 2001 Space Odysseys. These gentlemen are contemplating the monolith, black, impenetrable, hard, mysterious, full of promises. And here we have a microlith, tiny, black, hard, full of promises, just tiny, but so Seppo, I haven't seen him, but Po is there. Chris obviously is excused for being in Cape Town. David is there, and myself and Jan are watching, and you can also watch too. We don't have the old fancy lights. Okay, here it is.